Ladies and gentlemen, we are introducing the derivative. What? All right, so today is we're going to use the definition of the derivative to find what we call f prime of x. And this little tick mark on top of f of x is just the derivative of f of x. That's what that little guy represents. Okay? Well, coming up with the derivative, we started thinking about, okay, first off, derivative means slope, and we're trying to find the slope of your function. Think of slope as the change, the average rate of change of your function. So we've talked about a lot. Calculus is, an extension of physics, and physics is application of calculus. So one of the biggest things is velocity. And the change in velocity, the change in speed is acceleration. So it's always nice to be able to look at your velocity function and identify what's going on. Are you speeding up or are you slowing down? Is your derivative positive, meaning speeding up, or is your derivative negative, meaning you're slowing down? And that's, again, acceleration. That is, again, the derivative, which, again, is the change, average rate of change of your speed. So they started thinking about this. Okay, back in the day in geometry, we talked about a tangent line. You guys remember a tangent line intersects a circle in one spot, right? One spot. Well, they said, well, can we do tangent lines of functions? And the answer is yes, we can do tangent lines of functions, just assuming you know that it doesn't always intersect in one spot. So if we have this upside down quadratic, this parabola, yes, it would intersect in one spot. But if I have this graph here, it could go through the graph if you want to find the tangent line. Or if you have this graph here, which is kind of a wavy graph, it could intersect in more than one spot. So when you think of tangent lines of circles, yes, it intersects in one spot, but again, when you're thinking of functions, it could intersect in more than one. Okay? So how would one determine the slope of a curve? How would we find that slope? So the first thing they said, well, let's think of a secant line. You guys remember how to find slope of a line? To find slope of a line, we need how many points? 2. That's why we're calling this a secant line. So I have 2 points here. I have 1 point here, and I have 1 point there. All right, so we're going to call this guy x1, y1. We're going to call this guy x2, y2. You guys okay with that? And remember slope. Slope is m. And we know m is picnic table, margarita glasses. And how old do you have to be to drink? 21. You can be 12, but it's got to be lemonade. These would have to be lemonade glasses. And then we have subtraction up top. So again, we take our y2 minus y1 all over x2 minus x1. Oh my gosh, I did it again. It's not slop. So it's slope. Oh, is that what you're snickering about? Oh my gosh. My gosh. All right, so we got slope. We know slope is, right? Never gets old. All right, so now they're saying, well, that is a pretty good idea of the slope of that secant line, but they want the slope from this point right here. Yeah, and they're like, well, that's really not a good example of this tangent line. Here's this tangent line. Isn't that way steeper than that secant line? So they said, well, what if we moved that point a little closer, and a little bit closer, and a little bit closer, and a little bit closer, until they got so close they were on top of each other? Wouldn't that be the tangent line then? Okay, so the idea is they're trying to get this point to stay and this point to get closer and closer. And as you get closer and closer, let's say I choose this point here, that's a little bit closer. And then if you move that point closer, then it's a little bit closer. Okay? And they're like, well, how do we do that? How do we find the slope of a line at one point. And that's where the limit process comes in. Okay? So they said, okay, we have this arbitrary point, and they're going to use function notation. They said, okay, this arbitrary point, we're going to say this is x, comma, f of x. You guys remember f of x, same thing as y, right? And then they said, okay, we want this point to get closer and closer to this point. So they said, well, this distance from this point to this point is called the change in x. Have you guys seen that before, the change in x? Okay. So this is the change in x. I'll write that out. Now, in Greek letters, that little triangle is delta. So you're going to say delta x like 1,000 times today. Okay, delta x is the change in x. Okay? So they said, okay, if that's delta x, okay, the distance from this point to this point to get there, well, this would be x plus delta x. So whatever this value is, add this, and that will give you this x value. And then to come up with the y value, you said, well, just plug that into your function, x plus delta x into your function, and that's going to give you that. Okay, so you're going to see this now as your slope, y2 minus y1. They have f of x plus delta x minus f of x. And then they do x2 minus x1. That's x plus delta x minus x. This is just representative slope in function notation. And the weird thing here is this x plus delta x, that's just this point, this x value, starting here and adding this amount, whatever that is. Okay? Now, they did a little simplifying. Do you see what you can do on the bottom here? The x's are going to cancel. And now what you have is f of x plus delta x minus f of x over delta x. That represents the slope of that line. Well, they said, well, if I'm going to find the slope of that line, I want that delta x, that difference between these two, to be very, very, very small, right? We want that delta x to get smaller and smaller, almost to the point where it's 0. And they say, hey, that's kind of like a limit, using a limit process. So they say, well, if I find the limit as delta x approaches 0, I would be able to find the slope of that function at any x value that I so choose. And this, ladies and gentlemen, is the basic idea of the derivative, finding the slope. This is called the definition of the derivative, okay? And if that, me trying to explain that didn't really help, just know that we're going to use this function, okay, to find the slope of our function. Okay, so we're going to use this guy. This guy will be given to you. Okay, so let's go ahead and take this into action. Let's take a look to see what we got here. So on top, I've got slope definition of a derivative. Okay, how important is this? Oh my gosh, this is super important. It's in a big box. Mr. Gotch is highlighting it. If this is a quiz or test, Mr. Gotch would actually put this right on the quiz or test, and that way you would have it. But you guys are in Corona time. You guys can use your notes. So I hope you're taking good notes here. It says use the definition of this derivative to find f prime of x, to find the derivative. Well, the first function we got is f of x equals 2x plus 5. Does anybody know what this is a graph of? Line. This is a line. And we're going to find the derivative of this line. Okay? So let's giddy up. Let's give this a shot. As I take a look, I'm going to just rewrite this function right here. Understand that, guys, x plus delta x, this x and that delta x are like two different variables. That's like x plus y. Those are two different things. Or x plus, A for Anthony. or P for page, or what have you. Okay? Minus f of x. And then all over this delta x. All right, so we're going to go ahead and plug this guy in. Let me see what colors I got. Let's see. Let's try green today. So I'm going to use green for this part. Hopefully you can tell I'm using green. So I'm going to do f of x plus delta x. Basically, I'm going to take this function, 2x plus 5, and anywhere there's an x, I put a parentheses. And in my parentheses, I'm going to put my input. If this was f of 2, I'd plug in 2 there. If this was f of 3, I'd plug 3 in there. If this was f of 5, I'd plug 5 in there. This is f of x plus delta x, so I'm going to put in x plus delta x here. And then I'm going to subtract f of x. So I'm going to take this whole function and subtract it. So it's 2x plus 5 being subtracted. And then that's all divided by delta x. So before I go any further, any questions on my setup of this fraction? So far, so good. All right. So now it's just algebra from here. We know how to do algebra. Whee! Go ahead and distribute. So now I have 2x plus 2 delta x plus this 5. And then I got to distribute this negative. Whee! That's negative 2x and negative 5. And now that's all over delta x. I still can't find the limit yet, guys. If I plug in 0 right now, I'm in trouble. I'll have 0 on the bottom, and it's undefined. Doesn't mean there's not a limit. Just means I got to do some algebra still. Okay? Now, if you do this right, what do you guys notice on top? What do you notice about the pink stuff? It goes away. If you do it right, that function, the complete f of x, should completely be reduced or cancel out. So the 2x and the negative 2x, the 5 and the negative 5 completely cancel out. And now you have 2 delta x over delta x. That's like 2z over z. We can go ahead and cancel them. And I'm left with 2. Now, can I find the limit? You betcha. I can find the limit as delta x approaches 0 of 2. And again, think about this. The intended height at 2. That line is a horizontal line at 2. What's the intended height anywhere on that line? 2. Equals 2. We just found that the derivative of that function is 2. Okay? Now, give me another word for derivative. Slope. What is this a graph of? A line. And what's the slope of that line? 2. Did that make any sense that we just went through all of that to come up with your m value? No. Y equals mx plus b, right? Isn't m 2? Will you promise me never, ever, ever to do the definition of derivative if you have a line? Promise me that you'll never, ever do that ever again. Promise me right now. All right, so look at your homework. You guys have 1 through whatever odd, 1 through 11 odd. Let's do number 1 right now. What's the slope of this line? What's the derivative? Please don't do the definition of a derivative to a line, right? What's the slope of y equals 5x plus 4? 5. What's the derivative? Please don't do the definition of a derivative to a line, right?
Why'd you frame it like that?
Well, I'm making sure you understand what we're doing. You guys knew right away. I said, what's the derivative? You said slope. I said, well, what's the slope of this line? You said 2. And then it's like, oh, Mr. Gotsch, you made me do all that work, you dirty dog. I thought we're going to fisticuffs here. All right. Please never, ever do that again when you have a line. Okay, see the big picture. What are we doing? We're looking for slope. We want to do it as fast as possible. All right, now let's take a look. Not slop, slope. So as I take a look, I got f of x equals x squared minus 1. Okay? I use that limit process. Now you can't just say, the number in front. No. It doesn't work like that. This is a quadratic now, right? This is a parabola, a little different. So as we take a look, I'm going to use my little limit. Yes, you have to do it now. I've got my definition, f of x plus delta x minus f of x all over delta x. And I'm going to, again, do this part in green. The function that I have is x squared minus 1. So I'm going to rewrite it. So x squared, I'm going to do parentheses squared minus 1. And in the parentheses, if this was f of 10, I'd plug in 10 here, square it, and subtract 1. But it's not f of 10. It's f of x plus delta x. Okay? Are you guys okay with that? And then we got to subtract f of x. We're going to subtract that whole thing, x squared minus 1. That's all over delta x. Are we okay with that?
Yeah.
All right. So now we got to do a little algebra now. This is all this is algebra. This is like x plus z squared, or x plus t squared, or whatever. If you don't like the delta x's, you can always swap them out for whatever variable you do like. Just don't make it another x. Okay, but understand x plus delta x are two separate variables. Okay, and what are you supposed to do if you have a binomial and you square it? You must FOIL this guy. Okay, now let's go off to the side. I'm scaring somebody. Let's go off to the side and let's FOIL this thing. Because when you're going to FOIL this guy specifically a ton, so you might as well see what it turns into every single time. When I FOIL, I get x times x is x squared. X times delta x is x delta x. That's like x times z is xz. Okay? This is not delta x squared. It doesn't work like that. Delta x times x is, again, x delta x. And now delta x times delta x is delta x squared. Anytime you see this and you have to square this quantity, just simplify it to this step. X squared, I have x delta x plus x delta x. Well, how many of those do I have? 2x delta x's. It's delta x squared. Anytime you have to FOIL this, you can go right to this step now. Okay? So let's get to that step. I've got x squared plus 2x delta x, and then plus delta x squared. Again, that is this guy right here. And then I have this minus 1, include that, minus 1. Any questions on where I got this green part? I'm going to go ahead and distribute now. Whee! I've got negative x squared, and when I take a negative and multiply, that's a positive 1. So far, so good? If you do this right now, anything that's pink or whatever, fuchsia, or whatever color this is going to disappear. This guy and this guy cancel. And now what I'm left with, I've got a 2x delta x plus a delta x squared all over delta x. Okay? All right. Can I plug in 0 right now for the limit? Still can't do it. I got to get rid of this delta x. Well, what can I do on top? What do these have in common? That's x. I could do one of two things. I can factor out a delta x, or I could just reduce everything by a delta x. I'll do the first one where I factored out first. So you get 2x plus delta x. And now these delta x's in front, these monomials are canceling. And what I have now is 2x delta x. Oh, I have 2x plus delta x, excuse me. And now I've gotten rid of that denominator. Now I can find the limit as delta x approaches 0. All I do is plug in 0 for delta x. 2x plus 0 is 2x. And guys, that is my derivative using the definition of the derivative. And then you go, what? That's not slope. That's not slope. I just get a number for slope. Well, this is the function that allows me to find the slope of this function. And you're like, what? Let's take a look. Let's take a look at this graph. Any questions on why it's 2x right now? We were able to follow the algebra part. Okay, so if I take a look at x squared minus 1, y'all, you agree that this is a parabola been shifted 1 unit down, right? All I did is I graphed it, x squared minus 1. Okay? First value I want you to think of is x equals 0. You agree x equals 0 right there. Okay? So x is equal to 0. Well, look at the tangent line right there. You guys agree that's the tangent line, horizontal line going across at -1? What's the slope of that tangent line? What's the slope of any horizontal line? Horizontal has a z in it, 0. Plug in 0 to this. What's 2 times 0? 0. This equation allows me to find the slope for any x value. You just got to know what x value it is. It's going to find the slope. Okay, let's try this again. Let's try at 2. Here's 2 right here. Here's the tangent line at 2. Okay, first off, positive or negative slope for that tangent line? That's positive. If I want to know what it is at 2, plug in 2. What's 2 times 2? Well, doesn't that look like up 4 over 1? Up 4 over 1, up 4 over 1. Okay, this allows me to find the slope anywhere on this graph. Let's do one more. Let's say I'm at x equals -3. Here's -3. 1, 2, 3. Right about there. Here's the tangent line, rough sketch. Hard to draw on my calculator screen. Pretty good. Okay. Positive or negative slope? This thing's going down, right? It's going down. It's going somewhere. This thing's negative slope. Well, guess what? Plug in -3. What's 2 times -3? -6. Isn't this down 6? Down 6 over 1. Down 6 over 1, down 6 over 1. That's what we're doing. We're finding the slope anywhere on this graph with this function. Okay? Listen.
Say we're asked to like find the slope at like a certain point.
Yep.
And we get like something like 2x, so we just like do that.
Yeah, if they say, okay, find the derivative and then find a slope at 10. Once you find the derivative, then plug in 10. My answer is 20. Okay, great question. All right. Any other questions, y'all? Fantastic. You guys okay? Let's do this one more time. Find the derivative of this function. I wanted to do this one because it's got 2 x's now. Okay, so let's giddy up. Use my function. Definition of the derivative. I'll write it out one more time. All right. So I'll do the first part in green. So I've got f of x plus delta x. I'm going to take this guy, and anywhere there's an x, I'm putting a quantity. And in the quantity, I'm going to put my input, which again is x plus delta x. And 4 times x plus delta x. All right. Any questions on that first part? Then I'm going to subtract f of x. I'm subtracting x squared plus 4x. Again, I can't plug in 0 for this guy because of the denominator. I eventually got to get rid of this denominator or I can't find this limit. So we do a little algebra. Again, you remember this guy? How many times do we do this guy? 1,000 times. So the faster you remember this, oh yeah, that was what Mr. Gotch said up here. That's going to be x squared plus 2x delta x plus delta x squared. And then I'm going to go ahead and distribute. Whee! 4 times x is 4x. 4 times delta x is 4 delta x. And then I'm going to distribute here. Woo! Negative times x squared is negative x squared. Negative times 4x, negative 4x. And that's all over my denominator. If you do it right, anything that's pink should disappear. The x squareds cancel. The 4x cancels. And now what I have up here, I've got a 2x delta x, I got a delta x squared, and I got a 4 delta x. Okay? That's where we can do one of two things. Up here, we factored out a delta x and then reduced. Or what I usually do, guys, is I'll just say, okay, everything has a delta x, and I'm dividing by it, so just reduce a delta x from everything. That's usually what I do because it saves time and space. And just make sure you cross the delta x off of everything. So now I have a 2x. I'm left with a delta x there and then 4. And now I've gotten rid of that denominator, so now I can find the limit as delta x approaches 0. And anywhere there's a delta x, plug in 0. It's not for x, but for delta x. So I end up with 2x plus 4 is my final derivative there. Okay? So I just did the definition of a derivative to find the slope function for this guy, the derivative. Okay? All right, all right. Do we have any questions? Do we have time to do one from the homework real quick? Do you want to do number 5 real quick or no? Yes? All right, I'll do number 5, lightning fast. I'm going to do the limit. There's delta x approaches 0. I'm going to do f of x plus delta x, so x squared plus 5. And inside of that x squared plus 5, I'm going to do x plus delta x. I'm going to subtract f of x. I'm subtracting x squared plus 5. And that's all over as delta x. So again, this guy right here in green is the f of x plus delta x minus f of x all over delta x. Go ahead and FOIL this guy. We get the same thing. X squared, 2x delta x squared. And then plus 5. And then I distribute. X squareds cancel. Negative 5, 5 cancel. And now I have 2x delta x plus delta x squared all over delta x. Any questions so far? All of these delta x's are going to reduce by 1. And now what I'm left with is 2x plus a delta x. Now I can find the limit. I've gotten rid of that denominator. I can plug in. And I get 2x. Plug in 0. So I get 2x. There's my derivative. Final answer, I get 2x. Ladies and gentlemen, you have, I think, 3 more to do. I think you have 7, 9, and 11, so give those a shot. If you guys have any questions, we'll talk about it on Monday. You guys have a great weekend. Stay out of trouble.